All right, lean in. If you've been crying over your textbook because you think organic chemistry is a mountain of random letters, I have news. You've been lied to. It's not a memory test. It's a puzzle. Today we're going to stop memorizing and start decoding. By the end of this, you'll be naming molecules faster than you can name your own relatives. Look at the wrong path on the left. Mistake 1 is trying to memorize 100 molecules like they're French vocab words. Don't do that. Mistake 2 is invisible working, skipping steps in your calculations. If the examiner can't see your brain working, they can't give you points. And mistake 3, vague observations. Don't tell me CO2 is formed. You can't see a molecule. Tell me the, quote, effervescence turns lime water milky. We're going the codebreaker route. Learn the prefixes, master the functional groups, and apply them systematically. Think of a homologous series as a staircase. Every step up, from methane to ethane to propane, is just adding a plus CH2 Lego brick. They all have the same general formula and the same functional group. It's predictable. If the chain gets longer, the boiling point goes up. It's like a family. They all look a bit different, but they all have the same last name and the same chaotic energy. Now, we add the flavor, the suffix. This tells you what family the molecule belongs to. Does it end in ane? It's a boring single-bonded alkane. Does it end in anol? It's an alcohol. It's literally like a last name. If I meet John Smith and Sarah Smith, I know they're in the same family. Chemistry is the exact same. You see the ending, you know the properties. Easy, right? Alkanes are the saturated ones. They only have single bonds. They're stable, boring, and basically the accountants of the chemistry world. Alkanes? They're unsaturated, with at least one C equals C double bond. They are highly reactive because that double bond is just begging to snap open and grab new atoms in an addition reaction. Alkanes are a closed wall. Alkanes are a spring-loaded door. How do you tell them apart? The bromine test. If you drop orange bromine water into an alkane, nothing happens. It stays orange. Why? Because the alkane is a closed wall, but drop it into an alkene, and the spring door double bond snaps open, takes the bromine, and the water turns colorless. If it stays orange, it's boring, alkane. If it goes clear, it's a party, alkene. Pause for a second. We've all had that exam panic where your brain just goes blank. While I don't have a crystal ball, the Cambridge Education predicted papers use IGCSE trends to turn the could-be's into likely-to-be's. Treat these as a dress rehearsal. Practice your hacks on realistic questions now so you've found your rhythm by exam day. All right, commercial over. Let's get back to the science. Crude oil comes out of the ground as a giant, useless mess. Step 1. Fractional distillation to separate them by boiling point. Step 2. The heat scissors, cracking. We take long, useless alkanes, blast them with heat and a catalyst, and snap them into short alkanes for fuel, and alkenes to make plastic. It's basically molecular recycling. This is your field guide for the big three. Alcohols have the OH group. Carboxylic acids have COOH, and they bubble when you add metal carbonates. Esters are the fancy ones, made by combining an alcohol and an acid. They smell like fruit, and they have a weird naming rule. The alcohol gives the first name, YL, and the acid gives the last name, OAT. Ethanol plus propanoic acid equals ethyl propanoate. It's a chemical marriage. Polymers are just long chains made of tiny repeating units called monomers. Think of one paperclip as a monomer. Hook 1,000 together, and you have a polymer chain. In chemistry, we just draw one unit in brackets with an N next to it to show it repeats forever. It's the ultimate copy-paste. You have two options here. Addition polymerization is simple. The double bond in an alkene breaks, and they all just hold hands. No leftovers. Condensation polymerization is more dramatic. Two different monomers react, and they spit out a tiny water molecule, H2O, as a byproduct to make things like nylon. One is a clean link, the other is a link with a splash. Final tips for the AID-NERD. 1. Show you're working. Data, target, equation, substitute, answer. 2. Never mix up what you see with what it means. Don't say hydrogen is made. Say, I heard a squeaky pop. And 3. Count to 4. Every carbon atom must have exactly 4 bonds. If you draw 5, a chemistry teacher somewhere loses their wings. 4 bonds, always. Look at this map. It all connects. Crude oil, long alkanes, cracking, alkenes, alcohols, esters. It's not 100 facts. It's one system. You've cracked the code. Now go use those Cambridge papers, count your carbon bonds, and go crush that exam.